Welcome back to LeetCode Path to Pro. It's been like over a month since I recorded one of these, I think. Maybe even a couple months. Yeah, so getting back into it. I think this was the daily question quite a while ago. I just was like, I'll do this because it was already pulled up on my computer. So yeah, this is 1372, longest zigzag path in a binary tree. A tree problem, it's a medium. So the problem is you're given the root of a binary tree, and you want to return the longest zigzag path containing that tree. So zigzag path for a binary tree is defined as follows. So you can choose any node of the binary tree in a direction, right or left. So that's saying we don't have to start at the root. We can be at any node. If the current direction is right, move to the right child of the current node. Otherwise, move to the left child. Change the direction from right to left or from left to right. Repeat the second, third, fourth. So yeah, so as you can see here, we're just trying to find the longest path that goes back and forth down the whole tree. So you can see here actually the longest zigzag path where we go right and then left and then right again. So it's 4 nodes. They're returning 3 here. It doesn't actually start at the root. Because if we start at the root, we could go here, right, and then we couldn't go right again. We'd have to go left, so it would be 2. Here, it happens to be that it is. So yeah, cool. So we don't have to start at the root. Yeah, and I watched a video on this problem right before this. Shout out, I think it's LeetCode with Carter. I'll link him in the description because I was like, yeah, I've been doing LeetCode problems, but not like this. And this one would already be hard for me to begin with. So yeah, so I watched his video, and I'm gonna try to implement his solution here and explain it best I can. So he did recursive DFS, which I like. I like when implementing DFS, you can do iterative or recursive most of the time, and I usually prefer recursive. It makes more sense to me, and it's less code most of the time, which is nice. So first we're going to define like our DFS function. I don't know if you can hear this. So we're going to have self. We're going to have our root, which we're starting at, or whatever node we're starting at. But we are going to start the DFS at the root. But that doesn't necessarily mean the longest path is going to be. But we are going to start at the DFS at the root. Then we're going to have a left, just keeping track of which direction we just went. And then we're going to have to keep track of our depth, which is basically our result, like how deep have we gone. Yeah. And so to call this, we're going to return the max of DFS. So we're going to do self dot DFS. Where we have root dot left. If we go left, it's left is false, I think. That's going to be the confusing part, keeping track of that true or false. We'll figure it out. Right now I'm going to say, that's probably true. Because we just, I'm going to say false. Because we did go left last time. I'm saying it's true. And then the depth, right? And then the same little thing, same function call, but going to the right. It's like that metallic sound. All right. Yeah. So first, if not root, so that means there's no root, or return the depth. I guess, do we have to set the depth equal to 0 up here? Maybe. I don't know. I feel like we probably have to. And we'll say if left, so that means we did just go left, and then else is we went right. So if left, we want to call DFS self.search. And we're going to be starting at the root. I think we have to go right? Root.right. But that means left is true. Maybe. Yeah, we want to go right. So we just went left, it's true. Oh, because now we're going. Okay, I think I got it. Because now we're going right. So now when we call it this time, we're going to set the left thing to false. Yeah. And then we're going to increment our depth by 1. Okay. Cool. And then obviously for this one, maybe not obviously, but you know, for this one, this is if we just went right, so now we have to go left. We're going to set our left to true, because now we're going left on this call, and depth plus 1. But the other interesting thing about this is because we don't necessarily have to start at the root, we also have to we have to go the same direction twice in a row. We have to go the same direction again. But when we do that, we have to reset what our depth is. So it's going to be 0. And I can kind of explain that with the little draw arm here in a second. So here we're going to go right again. Set this to false. And that's 0. And then outside of this, we have to return the depth again. So yeah, shout out to LeetCode with Carter. This is his solution. Let's see if this works. Yeah, so oh, I didn't indent this stuff. Okay. Okay, so we messed something up. And here, this would be a good time to draw some stuff. So the nodes here don't matter. Dang, why is it always blue to begin with? We can do a little better than that. There we go. So here we'll have our tree. Just have to make sure it's easy to tell. Okay, so for here, right, we're going to start the DFS call at the root. That's what this is. And we can go either left or right. So if we go left, we're going to get boom, boom. So that's a depth of 2. Right, and that's pretty good. Looks solid. But the problem is if we go right and then right again, which isn't increasing our result at all. Our depth is still, according to what we know, is still 2. But if we go right again, now we can go left and then right and then left and then right. So now our depth is 1, 2, 3, 4, and that's deeper than 2. So that's our result. So that's why we have to make these calls. That's why we have to make these calls to Okay, let's try going the same direction, you know, a few times in a row. And I wonder if... So we're returning 0 for all these. I feel like that's because he was doing... Did he do return max here as well? Doesn't really make sense. But I'm doing something wrong with these. I know, for sure. He's also using the keyboard, also like only, which I thought was cool. So yeah, it's very pro coder stuff. I mean, technically, I'm basically a pro coder now. So yeah, that was it. So yeah, I just had to return the max because whereas before, I think what was happening is it's calling both these, and so no matter what happens, every time we're just going to reset our depth to 0. So that's why when it goes through all these and it goes through the whole tree, doesn't matter if it's left or right, we're running the correct DFS, and then we were also running this DFS, which turns it to 0. But what we really want to do is see which one of these works better and gives us, you know, a larger depth. Cool. And that's fast. Damn. That guy's a beast. Lead code with Carter. Yeah, I think this solution is O of n time, right? Because we're going through each node once. And then the memory, because it's recursive, we're gonna be putting things on the stack. So it should be O of n time as well. Yeah, and I'll just show this solution here because yeah, there it is. Cool. Appreciate y'all watching. Getting back into it. How do I exit this? Oh shit. I don't know how to stop the screen. Let's see. Click to stop screen. Or use the touch bar. Stop movie. Movie. Command escape. Oh, option. No, I don't want force quit.